Let's say a compliance team deploys a RG system. It's backed by thousands of internal policy documents. An employee asks whether a specific transaction requires regulatory approval. The system retrieves 3 documents from the correct domain, all with high similarity scores, and generates a confident answer.
Right, but the output is entirely wrong.
Mhm.
I mean, it was based on a superseded version of the policy because the current version used different terminology, so the retriever never found the current policy.
That's the thing. The information was in the system and the retrieval was technically successful, but the answer was still wrong. This demonstrates a structural reality about retrieval augmented generation. RG doesn't solve the knowledge problem, it relocates it.
But if the retriever successfully found documents about regulatory approval in the exact right domain, the architecture itself isn't necessarily flawed. That sounds like an issue of vocabulary mismatch. The user asked a poorly phrased question.
It's not user error, it's a fundamental system failure driven by how standard dense retrieval operates. You have to look at the mechanics. The system doesn't read text the way a human does.
Okay. It converts both the user's query and the underlying documents into high-dimensional vectors. You're mapping language onto a massive geometric space.
Correct. You convert paragraphs into coordinates. The system then measures the distance between those coordinates. It returns the documents whose vectors sit closest to the query vector in that geometric space.
So semantic similarity is operationalized entirely as geometric distance.
Yes. It assumes that geometric proximity indicates the correct answer. And that creates a specific class of failure. I mean, this mechanism works for queries where the question and the answer share vocabulary and conceptual framing.
It breaks down completely when they don't. But if that's true, why does it work most of the time? If embedding models are trained to capture semantic similarity across massive corpora, shouldn't that shared conceptual territory be exactly what you want for most queries?
It is what you want for conceptual queries. The failure occurs because there's a strict distinction between similarity and relevance. Similarity relates the query to a document. Relevance relates the document to an answer.
Those are often treated as the same thing in deployment.
Right. And they are entirely different properties. A document can share the same topic, the same domain, and identical vocabulary with a query. It will score very high on similarity.
But it can contain absolutely nothing that helps answer the question.
Exactly. So a document is highly similar, structurally adjacent, and practically useless, or the inverse happens. A document can be dissimilar in its surface features and contain the exact piece of data needed.
RG architectures conflate these two distinct properties. They measure similarity and assume they are retrieving relevance.
That is the mechanism behind the compliance failure. You have a superseded policy document and the current one discussing the same regulatory domain. They use similar language.
In embedding space, they are neighbors.
Yes. The retriever has absolutely no mechanism to distinguish between those neighbors on the basis of currency, version, or authority. It only measures proximity.
Which brings us to the geometric trap.
The geometric trap is the assumption that a high similarity score equals factual relevance. You are substituting a learned distributional association for actual truth.
That sounds like a retrieval problem, not a model problem. I mean, the embedding model is optimized for the average case across a vast data set.
It's optimized for queries where the relationship between question and answer is mediated by shared conceptual territory. It is not optimized for exact matches. Precise keywords, abbreviations, proper nouns, and technical identifiers compress very poorly into embedding space.
But embedding models should capture those specific entities if the training data was broad enough.
They capture the general neighborhood. A query about a specific internal project code or a regulatory reference number will retrieve documents that are semantically adjacent. It retrieves documents related in topic rather than the single document that actually contains the exact identifier.
The embedding model smooths over the exact specificity that makes the query meaningful to the user. It returns a conceptual neighborhood instead of a precise location.
And it doesn't degrade gracefully when an exact match is what the query requires. The system returns the conceptual neighborhood, and the model generates an answer based on that adjacent incorrect information.
That complicates the deployment reality significantly for anyone building these systems. You're seeing ERG adoption climbing rapidly in high-stakes regulated, legal, and operational domains.
Right. The Menlo Ventures annual survey recorded enterprise RH adoption jumping from a third to a half in a single year. It's the fastest growing architectural pattern in the industry.
But in those precise domains, currency and specificity are exactly what the user's querying for. A compliance officer isn't asking for a conceptual summary of a regulatory framework. They're asking for a specific string of text.
And because the system conflates similarity with relevance, it fails precisely on those queries. The most dangerous aspect of this failure mode is its invisibility.
If the system fails precisely on specific queries, the failure rate should be obvious to the developers. A system that returns nothing is visibly broken. You can log an empty result set and engineer a fix.
Dense retrieval's failure mode is optimized for invisibility. It always returns something. It returns the nearest neighbors, even if those neighbors are incorrect.
The system returns the wrong documents, and the generation model synthesizes an answer based on that incorrect information.
The system answers confidently regardless of whether the retrieval actually succeeded. A system returning the wrong documents confidently can operate for months before the output quality degrades visibly.
You know the answer was wrong at the output level eventually, but you do not know why the system arrived at that conclusion.
Issues like fixed-size chunking strategies and end-to-end evaluation metrics compound this invisibility by severing context and masking retrieval errors. The retrieval layer is doing the actual epistemic work.
That phrase requires clarification. What do you mean by the retrieval layer doing the epistemic work?
The language model's job has shifted from recollection to synthesis. It is no longer operating as a memory bank trying to retrieve facts from its training weights. It operates purely as a synthesizer of the information you provided.
You hand it a stack of documents and ask for a summary. If you hand it the wrong documents, it summarizes them perfectly.
That's the issue. The model is entirely dependent on the documents provided to it in the context window. If the retriever fetches a superseded policy, the model synthesizes a highly confident, completely false directive.
Okay, that changes the question. If the failure is invisible and structural, upgrading the language model doesn't fix it. You are just buying a better synthesizer for the wrong documents.
Research consistently shows that improving retrieval quality produces larger gains in end-to-end RAG performance than upgrading the generation model. A better retriever outperforms a better model.
That contradicts how the industry operates. If you are making deployment decisions today, the language model is the expensive, visible, frequently updated asset.
The retriever is treated as set-and-forget infrastructure. It is configured once during the initial build and rarely revisited.
Which means the prioritization is completely inverted. We spend time evaluating model benchmarks when the retrieval layer is where the structural failures originate.
The reason most production systems use only dense retrieval is not technical difficulty. Dense retrieval is simply the default in most ARD frameworks. Builders accept the default and assume the vector math maps to factual relevance.
So the fix isn't the model. What are the required engineering shifts that actually solve the geometric trap?
Resolving this requires moving away from default dense retrieval. The first required shift is implementing hybrid retrieval. You must combine dense vector search with sparse keyword matching.
How does that mechanically solve the problem? Dense vector search handles the conceptual mapping. What does sparse keyword matching provide?
Sparse keyword matching operates fundamentally differently. It doesn't map concepts into geometric space. It scores documents based on exact string matches and term frequency. If you search for a specific project code, it finds that exact code.
The two approaches fail on different distributions of queries. Dense retrieval fails on precise terminology. Sparse keyword matching fails when the user and the document use different vocabulary for the same concept.
When you combine them, you cover significantly more of the distribution. The sparse retriever anchors the search to exact terms. The dense retriever captures the conceptual intent. Most out-of-the-box RAG systems tend to use only one.
But hybrid retrieval still relies on measuring the query against the document text. It doesn't solve the issue of the superseded policy if both documents contain the exact same keywords.
That is the second required shift. Geometric proximity completely ignores temporal authority. To prevent a system from retrieving a highly similar but long superseded policy, the architecture must move beyond raw vector math.
You have to implement explicit metadata pre-filtering.
Yes. You must hardcode structural rules that restrict searches strictly to current versions, specific jurisdictions, or active document tags. This filtering must happen before the vector calculation even begins.
That enforces relevance outside of the embedding space. You are defining the rigid boundaries of what is acceptable to retrieve before measuring similarity.
It is the only way to guarantee currency or authority. The embedding model cannot calculate authority. It can only calculate distance. You have to supply the authority through rigid architecture.
That fundamentally compromises the appeal of the architecture. The entire promise of RAG is unstructured data ingestion. If you have to hard-code structural rules and manually tag document statuses, you are just rebuilding a relational database.
You are building a hybrid system. The elegance of dropping raw PDFs into a vector database is a prototyping illusion. Production systems require rigid structure.
So the unstructured data still requires heavy structured metadata. That makes deployment significantly more expensive and labor-intensive than the framework suggests.
Which is the more expensive version of the problem. You either pay the cost in data structuring upfront, or you pay the cost in invisible compliance failures later.
That changes how you have to view the entire architecture. RAG isn't a failed architecture, but its name describes its limitation. It only augments generation with retrieval.
It offers zero inherent guarantee that what is retrieved is what is needed. The elegance of the architecture is real. Instead of retraining every time your knowledge base changes, you update the document store.
But that elegance masks the engineering requirement. The systems where RAG performs most reliably share a set of specific properties. Their knowledge base is well-structured.
Their queries are representative of the document vocabulary, and crucially, their retrieval quality is measured independently of output quality.
If you are making deployment decisions, you must recognize that the gap between a median RAG deployment and a reliable one is not a model gap.
It is an engineering gap, and it sits almost entirely in the retrieval layer.
There is a separate assumption that scaling context windows will render this irrelevant. If a model can process 2 million tokens, developers assume they can simply bypass retrieval and load the entire database into the prompt.
That doesn't solve the geometric trap. It simply relocates it again. If you feed the model superseded policies alongside current ones, you are asking the model's attention mechanism to sort out the authority instead of the retriever.
The trap moves from the vector database into the model itself. You still have the exact same problem of distinguishing relevance from similarity.
The system doesn't inherently know what matters. The compliance system did exactly what it was designed to do. It was built to retrieve similar documents. The user trusted it to retrieve relevant current ones.
Those are not the same category. The design had a construct validity problem. In any context where currency, version authority, or specificity matter, that difference is everything.
The compliance system didn't fail because the model hallucinated. It failed because the retrieval succeeded.